Hello and welcome to 5-Minute Math. Today we are looking at day 9 of our 12-day review of 4th grade math. And as always, we are using items from a 2017 released STAR test from the state of Texas. So today our journey is going to take us into some more geometry. We're going to be looking at how we can classify triangles based on their side lengths or based on their angles, and then also look how we can classify two-dimensional shapes based on the absence or existence of parallel and perpendicular lines. So triangles are not simply triangles anymore. Up to the 3rd grade, triangles were simply 3-sided shapes, but now we need to start looking at them a little bit more closely in the 4th grade. So Leela made a triangle that had one 90-degree angle. So we know we've got one 90-degree angle. So let's make it look like this. And two acute angles. And so we will say this is our one 90-degree angle and two acute angles. So what this means is this is a right triangle. One of the ways that we can classify our triangles is based on the angles that they have. So if you have a right triangle, that means you have one angle. So in this case, it's this one right here. That is exactly 90 degrees. So I'll put that right here. One 90-degree angle. If you ever look at an obtuse triangle, then that is going to have just one obtuse angle. So obtuse angles are angles that are greater than 90. So 91 to 79 degrees. If you have 180 degree, you're not going to be able to have an angle which is going to be a straight line. And then finally, if you ever have an acute triangle, that's the difference. Acute triangles have all three acute angles. And acute angles are any angles that are less than 90 degrees and greater than 0. So we're not going to, this says right triangle. Let's look at our answer choices here. We're not going to say that because all three angles are not 90. You can't have, if you have three angles that are 90, this is what you have. And it's impossible to make it a triangle. Actually, that would look more like this. You'd have 1, 2, 3. And that's not a triangle, that's almost a square or a rectangle. It's not an obtuse triangle because the largest angle is not obtuse. 90 degrees is a right angle. It's not an acute triangle. There are two acute. I bet you this was probably the number one chosen incorrect answer. There are two acute angles. Whenever you have a right triangle, the other two have to be acute. But remember, that's the key word there. Acute triangles have all three. Like this right here, this original triangle I drew is an acute triangle. So that's not going to work. It's going to be A. It is a right triangle simply because there is one 90-degree angle. So A is our answer. Number 2, we're going to be looking at some polygons. Remember, polygons are any shapes that are closed and straight. No curves, no arcs, nothing. So these three are polygons. Now, if we wanted to name them, we could. We can name them based on their sides. So this is an 8-sided shape, so that's an octagon. That's a 5-sided shape, so that's a pentagon. And this is a 6-sided shape, so that's a hexagon. But that's not really the question they're asking us. They're asking us which description best represents this group, and then look at your answer choices. Perpendicular, parallel, perpendicular, acute, obtuse, and obtuse. We're either looking at the angles or we're looking at the sides. So let's look at one. Let's start with A here. Polygons with perpendicular and parallel lines. Well, the problem is there are no perpendicular lines in these shapes at all. Perpendicular lines form 90-degree angles. They form right angles straight up and straight across. There's none of those in here. There are some parallel lines here. So those two sides are parallel. Those two sides are parallel. Those two sides and those two sides. So octagon, this type of octagon, a regular octagon, has every side is parallel to an opposite side. There are no parallel sides here in this pentagon. There's no sides. Parallel lines are lines that run the same distance apart from each other and they never meet. The hexagon has parallel lines here as I'm drawing top and bottom and the two sides, but not all of them, and then there's no perpendicular lines. We're going to say a no on this one. Polygons with perpendicular lines only, that is not the case. There are no perpendicular lines. If I were to draw a square, well now look, I've got perpendicular lines. I've got those four corners make four perpendicular, become as a result of four perpendicular lines. Polygons with acute and obtuse angles. Remember, acute angles are less than 90 degrees. And here's the thing with these shapes. If I were to draw a 90-degree angle, like right here, so this is my 90-degree angle. So obviously, this angle is obtuse because it's larger than that. If I were to draw a right angle right here on this pentagon, the angle is slightly larger. If I were to draw a right angle right here on this octagon, the angle there is slightly larger. These are regular shapes, which means every side length at every angle is exactly the same. And you can tell just because of the way that they look and that they're all equidistant and that the side lengths are the same and also the angles appear to be the same. So if you were to draw a straight line in any of these angles to try to make a right angle, what you would find is that you couldn't find anything that is lower than 90 degrees, which means they're all obtuse. So that's going to be a no, but my answer is going to be this right here. The only thing we can say about these three shapes is that they have obtuse angles only. So whenever you get into shapes that have more than four sides, you have the possibility of getting shapes that have only obtuse angles. And then finally, we're going to continue looking at two-dimensional shapes, but now we simply have to draw it ourselves. Landon drew a flag with exactly one pair of perpendicular sides. Which could be the shape? Well, let's see if I can draw each of these and we'll take a look at it that way. So my right triangle, let's just use the one I had right here. So I've got my right triangle, there it is right there, and look, it does look like it's got a pair of perpendicular sides right here and right here, so that's a pair. So we're going to say question mark, but that could be it. An acute angle, let's draw this right here. Here's an acute angle. Acute angles are never going to have any perpendicular sides because these always have 90-degree angles. Perpendicular goes with 90 degrees. There are no 90-degree angles in an acute triangle, or else it would be a right triangle. Rectangle. All right, so let's draw a rectangle. We know what rectangles look like. Here's the problem with that, is a rectangle has more than one pair of perpendicular sides. So these two sides form this perpendicular angle. These two sides form this. And then all the way around, you've got these four. So that's got too many. And then same with square. Rectangles and squares are going to be the same in this respect. A rectangle is simply a stretched out square. So there's too many pairs. And so we're going to say no on this. So our answer is going to be F, right triangle. It only has one pair of perpendicular sides that make up that 90-degree angle. So if you enjoyed this and you want to learn a little bit more about what's coming up next, you can get on my website, aarondaffern.com, and you can check out day 10.